Hi, my name is Noah Gift, and today we're going to talk about Practical MLOps, and I'm going to take you through a 4-hour session that really goes from the very beginning, so how to set up continuous integration. Then we move on to how to do a cloud-based development environment and how to get all those factors involved. Then how to move into microservices and then take those microservices and put them into production. Finally, I get into using MLOps, how to use the tools available for MLOps, and then put those into production using a service called AWS App Runner. So really, this is kind of a end-to-end, how do I get started with MLOps in the quickest amount of time possible? And so look forward to getting started. Let's go ahead and go. Now that we've got kind of a high level here about MLOps, what I thought I would do is basically just share this chapter 1 and just talk about this for a second in terms of some of the key concepts of introducing MLOps. And this is the rough draft of the O'Reilly book, Practical MLOps. But in a nutshell, as I mentioned earlier, we've got this rise of machine learning engineer. We've got the rise of the data engineer. We have really a degradation, I guess, of data science. And so how can your organization get these capabilities? That's really the key takeaway. And so some of the things that I'm highlighting here that I'll point out are that SageMaker, Azure ML Studio, Google Cloud AI platform, which is called Vertex AI. These are all capabilities that ML engineers are using. So this would be almost like a checklist: is can your organization put these capabilities into play? Also, containerized workflows. That's another thing that we're seeing a lot in the ML ops capabilities of organizations. They're using Kubernetes, they're using container registries. We'll get into some of those things later. Also, serverless technologies. One of the nice things about building technology around serverless is that it really cuts right down to the problem. You can take your business logic and put it into production. AWS Lambda is a good example of that. AWS Athena, where you can do SQL queries and talk to things. Google Cloud Functions, Azure Functions. And then also another component is the specialized hardware, right? We're seeing that people are using GPUs, they're using TensorFlow processing units, they're using Apple chips. Really, one of the things that's almost inherent now to MLOps is that somewhere, some kind of specialized hardware is in play. In fact, I was at the Tesla headquarters a couple weeks ago at their AI day. They're building their own AI chip. So pretty much anyone in AI, ML, they're building their own hardware. And so it's something to be aware of. And then another one here that I'll just maybe highlight real quick is that we are also seeing platforms at play where I think organizations are realizing that they don't want to build things themselves. They want to use high-level tools: Databricks, Hadoop, Spark, Snowflake, Amazon EMR, Google BigQuery, right? And ultimately, machine learning is deeply tied into cloud computing. And I think that's one thing that's really important to be aware of, is that if you're doing MLOps, not 100% of the time, like a good example, counterexample would be Tesla. They have their own data center, but many companies are using cloud computing because it has the elastic capability that you can take advantage of. And so, what is MLOps? I think one way to think about MLOps is it's this concept of why isn't ML engineering 10 times faster, right? That's really a big component of it. And one of the ways to consider this is that with MLOps, you have this concept of Kaizen, right? So in Japanese, it means improvement, and it's something that happened after post-World War II, that a lot of these continuous improvement processes made the Japanese auto industry really the superior auto industry for quite some time. And even today, we have incredibly powerful vehicles and great manufacturing that comes out of the Japanese automobile industry because they have this concept of continuous improvement. So how do you use those philosophies in your organization? One way to consider it is to say, if it's not automated, it's broken, right? And so if you have things in your company that are not automated, like the testing is not automated, or for example, the machine learning training is not automated, then really you're going to have a tough time doing MLOps because you're not able to actually use this concept of continuous improvement. So that's really the precursor, as I mentioned before. And what's the similarities now between DevOps and MLOps? So one of the things to be aware of about DevOps is that it's a set of technical and management practices that aims to increase an organization's velocity, right? So that's really the goal of DevOps, is that you want to increase the speed of building high quality software. And so how do you do that? Well, you use continuous integration. And what are some of the things that you can do with continuous integration, and what are some of the services? So SaaS build servers, good examples are GitHub Actions, which we'll get into in a second, Jenkins, GitLab, Circle CI. There's also cloud native build systems, and it's really critical to be aware that this is something that's a must-have. It's a non-negotiable requirement for doing DevOps. You have to have continuous integration. You have to have a build server. Another must-have requirement of DevOps is this concept of continuous delivery. So, for example, are you able to automatically push your code into the website, or put it into a mobile app, or put it into a self-driving car? That's continuous delivery. You're delivering high-quality code, and you're constantly improving and doing a feedback loop. Likewise, I think in many cases here, we're seeing that a microservice is most likely involved in DevOps. And the reason for this is that you can actually associate the business logic directly with what it is that you're trying to solve. Finally, we also have infrastructure as code. So infrastructure as code means that it's the process of checking the infrastructure into source code repository, deploying it to push changes to the repo, and this is really a configuration that just gets checked into your GitHub repository. And because we have cloud computing, and cloud computing is infinitely configurable, we can actually just tell that repository to do everything we want to do. Some examples of infrastructure as code include AWS Cloud Formation. There's also multi-cloud options like Polemy and Terraform. Also, a couple other things to point out here is monitoring and instrumentation is critical to doing MLOps and DevOps. So examples of that would be New Relic, Datadog, Stackdriver. And why is this so important? Well, why is collecting data important for doing data science? Well, it's because the data itself gives you the ability to do things like exploratory data analysis, clustering, predictions. Likewise, if you don't have monitoring and instrumentation for your software, how could you possibly know it works, right? It's really data science for code that's in production. And then I guess a couple other things here is effective technical communication, right? You need the ability to, communicate what's working, what's not, and that's a component of DevOps. And then effective technical project management. So if you can't break things down into discrete details and assign a task to another person and get it done in a timely manner, then it's impossible for you to deliver software reliably. So that's really kind of in a nutshell all of the core components that are critical to DevOps, which again is a precursor to MLOps. Let me just show you really quickly related to this. I was just working on a demonstration yesterday to a course that I teach at Duke, and I'll just show an example of this in action. So here we go. Here's kind of a picture of what I would call continuous delivery, and we can look at this diagram, and I'll also potentially just share this in like chat or something like this. So let's go here. There we go. So basically, if you take a look at this, this is something that I call the 6 components of continuous delivery. And I think it oftentimes comes as a shock to a data scientist because they've only been focusing on this business logic here, right? They're focused on, the Jupyter Notebook, right? Or they're focused on Kaggle, And I think one of the issues is, of course, it's important. Of course, you need business logic, but you also need these other 5 components. And really, if you don't have these 5 components, you can't do continuous delivery. If you can't do continuous delivery, you can't do MLOps, right? And so this is really the key here, is to be aware of these 6 components here. And so let's just talk about this real briefly. So the first one is we have source control. And with source control, there are many different options for source control. You have GitHub, you have GitLab, you have Bitbucket, you also have cloud native source control. And so you must have a great process for using source control. And also you need to have some of the methodology down. Like, so, why is it we care about source control? What are the problems that it solves? And it's important to know, what these things are. Likewise, in terms of your build server, I think this is also something that many data scientists are not familiar with. Like, hey, what's a build server? What does it do? What problem does it solve? I think the main thing to be aware of with a build server is that it is a tool that is really just a virtual machine that lives somewhere, or a container that lives somewhere that can execute commands that you've told it to run. That's really all it is. Most likely it's a SaaS offering. You can do it yourself with things like Jenkins, but most likely it's a SaaS offering, and it listens to the source control repository via an event, right? So let's say the main branch, when there's a change made, it'll trigger whatever it is you told it to do. Oftentimes in a DevOps environment, it's going to trigger running my code, testing my code, linting my code. Next up here, we have the development environment. And this is something I'm going to set up in a second, but it's really important to be aware of this fact of, the development environment. It's easy to kind of discount how important it really is. I think many people have made a mistake by using their laptop as a development environment. And the reason why is that your laptop is not actually running the same version of the operating system that your production environment does. Let's just say 95% of people that are developing software or doing machine learning engineering are going to be using Windows, or they're going to be using OS 10. Almost never are you deploying to those targets. Sometimes you are. I mean, there's environments that do run Windows, but almost nobody runs OS 10. And for the most part, it's going to be some kind of specialized Linux operating system. So it's much better, in my opinion, to really be careful about going through, making sure you have a cloud-based development environment, and building out that cloud-based development environment in a way that makes it easy for you to simulate as much as possible your deployment environment. And so what I'm going to show today is I'm going to get into Cloud9, and I'm going to walk through some of the things you can do with Cloud9 and why I think it's so important. And then once you've got that set up, then you can start writing your code. And so really with writing your code, a few things to be aware of here are that I think microservice is really the way to go. And with microservices, what's nice is that it really lets you focus directly on solving the problem versus focusing on fighting some object-oriented framework or building. A lot of web frameworks are actually really older technologies that were focused on mapping SQL to HTML to build content management sites. Like, I think Django is basically that. It's like a content management system. So like, why are you using that to build microservices? Complete, not only overkill, but the wrong tool for the job. Instead, if you look at tools like FastAPI or Flask and Python, they're really specialized for building machine learning services. They work very well. In fact, many MLOps people are using these microservices. And so once you've got that working, then you can go inside of here and use your infrastructure as code to deploy this into some kind of an environment like a serverless, let's say AWS Lambda, or maybe Elastic Beanstalk, which is kind of a transitionary technology, or AWS App Runner, which is a PaaS or platform as a service offering. So again, all of these 5 components here are a lot of times not done by the data scientists. They're not aware of those other components, but fortunately they're fairly straightforward to do. And then you can map your business logic into the microservice, and then you can essentially do MLOps. So this is really a key takeaway here, is to be aware of this fact of tying in these 6 key components. And one other thing I'll point out is, if we go back to this diagram here, one of the things that I'll look through is, I think it's the last picture here. So if we kind of look at even a lower level, and I'll just throw this doc here, that if you look at a kind of a lower level component for continuous integration, continuous delivery here, is that you could even boil it down to an even simpler start. And if the other one is confusing to you, like, hey, there's 6 components, let's boil it down for a second to these 3 components. And really, you have source control, which again could be GitHub, GitLab, Bitbucket, whatever it is. And then we need to break down, why do we have source control? Like, what's the point? It's the source of truth, right? So it's really the place where we know that the code works. We can look at the version, we can see exactly what happened. Additionally, we have the ability to version our software, so we can branch it into production environment, staging environment, any environment. Also, we can collaborate, right? So that's really the key reasons here for source control. Again, many data scientists don't use source control because they're using a notebook. The build server, we talked about this, but it's GitHub Actions is an example, Google Cloud Build is an example, AWS Code Build. And now the question is, why do you use a build server? The key reason for using a build server is it answers this question: does it work? It's really that simple. Like, that's what a build server does, is it answers the question, does my code work? If you only have source control, then you don't know how to answer the question, does it work? Right? So that's really a big key takeaway. The other thing that I'll point out as well is that in terms of development environments, this is something to be aware of, is that you again have many different options: Cloud9, GitHub Codespaces, Google Cloud Shell. But the key takeaway is that ideally you're developing an environment that's as close as possible to production. So if the other diagram that I showed is a little bit too complex to start with, this is a good one to start with, and make sure you have a mastery of the material. So let's we did a bunch of theory for half an hour. Let's get into a little bit of specifics here, and let's get into just doing this. Let's build this out and see how quickly we can do it. So what I'm going to do is I'm going to start with something that's simple, and I'm going to go to GitHub, and I'm going to go to creating a new repo. Just go here, and we'll call this MLOps and Starter Kit, something like that. That looks pretty good. MLOps Starter Kit. And so the way I would start this out would be, put a little description in here. This is a start of a MLOps project. All right. And I like to always have a README file, a gitignore file, put in a little gitignore for Python, and then say create repo. And what's nice about what's happening with a lot of these tools is that they give you the ability to edit right inside of GitHub now, right? So again, this is really like a revolution in developing software now. You can pretty much do everything in a browser. So your local desktop is pretty much irrelevant now. So if we go here and we click on your code spaces, I can actually click on this feature, say new code space, and look for that repo, which we called MLOps something starter kit. There we go. And I'm going to go through here and say create code space. And what's awesome about this is that, and I use this quite a bit, is that basically I don't have to worry about a bunch of stuff that's annoying on my desktop, right? It's all ready to go for me, and I can just immediately start writing code. The first thing that I do when I'm in a new environment is that what I'll do is I'll actually create a Python virtual environment to protect my Python interpreter and make sure it's only referring to a specific repo. So in this particular environment, it's called virtual env. Let's make it a little bit bigger. Virtual env, and then I like to put it inside of a hidden directory inside my home directory so that it's kind of out of the way and I don't accidentally check it into source control. There we go. We got virtual environment. And then once I've done that, I can go ahead and source it, which is like this. And now if I say which Python 3, you can see that it's using the Python 3 that's in my virtual environment. So that's kind of step one. And then the next couple things that I'll do is I'll just touch a few files, and a touch command will just create basically an empty file for me. So I usually create a requirements file, and then I'll touch maybe like a hello file, and then maybe like a test file, test.hello.py, and then also like a make file. And I like to use make files because they're a way of capturing commands. And you can see here that, look, it's even able to be smart about this and know all the names of the files here. And so let's start with the make file here. What do we put inside? If I go back to this, to GitHub real quick, let's go to another project I've got set up called PyTest. And I usually just copy an old make file. And here's an example of one that I can just copy, and then I just throw it in there like this. And what's cool about this is that we can see that all it is, a makefile syntax, is it has a command, and then it has underneath here some bash code. So what this does, it says look inside the requirements file and install my software and upgrade the Python packaging tool if it needs to be upgraded. This one says run some tests. This one formats my code right here, and then this one lints my code. And then if I run all, it does all of them at the same time. So first I'll need something inside of here, this requirements file. So most projects that I personally use, I use PyLint. Let's also use Black, the formatting tool, and let's do PyTest. That looks about right. And then I can actually say make install here, and it'll just go through and install what I need for my project. Okay, this looks like it's good to go here. And from here, what I can do is now go into the hello file here and just make a script. So I'll go through here and just make an add function, which is a good one to play around with, and it just returns back x plus y, and we can call it. We can just say print add and put in, 1 and 1 should be 2. Let's go ahead and try that, and we can say Python add. Or Python hello. There we go. We can see it does 2. If I change it to 2 and 2, it'll be 4, right? So we see we've got a very small script. If I say make lint, notice that what the lint command does is it checks for bad syntax. And so this is actually very helpful, because if I created an empty variable, right, then if I say make lint, right, it'll just go through here and just say, hey, we don't like this, we got an error, let's fix it, and then I can comment it out. So linting is very important for a language like Python, because it doesn't have a compiler, and it really catches runtime errors that could really cause you big problems. And so using either something like Flake 8 or PyLint is, in my opinion, is mandatory for a Python project. It's a mandatory best practice for DevOps and for MLOps. So again, we got this small little function. I can also write a test method here as well, because PyTest makes it really simple. I can just say from hello, import add, and then I can just write a test function, test add, and then I can just say assert 2 is equal to add, or equal is equal to add 101. And then if I say make test here, there we go, it passes, right? If I give it the wrong test value, right, that's an incorrect test value, it'll fail, and it even tells me exactly, it says that it should have returned 2, but it returned back 3, right? And so I could say, uh-oh, we got a bad test, I need to make the test accurate. There we go, and now we can fix it. So really, these things are so simple to do, and it's surprising more people don't do this for all their projects. You know, add a makefile, add a linting, and add a test. It doesn't mean you need to go crazy and go test every single thing, but a little bit of logic testing, I think, is a good idea, especially if it's something that's mission critical. So once you've got all this set up, then I could even say make all, right? If we go back to the makefile, remember, make all is install, lint, and test, right? So make all, there we go. Now, if I want to get really fancy, I could even, and this is totally optional, but I could even run make format, right? And then you can see it will just kind of clean the code up a little bit. That's what that Python black tool does. I personally like it because I like being lazy and having tools do all the work for me. But once you've got this set up, then I can just say get status. There we go. And I can say get add. And we can commit this, adding initial code. There we go. And then we can say get push. Perfect. Now, this, if we go back to this picture here, we basically are focusing mostly right here, but we haven't done the build server yet. So let's go ahead and set up the build server. Now, and by the way, we're first just using code spaces, but I'm also going to do Cloud9 as well. So we have GitHub. We're kind of testing things locally. We're making sure things work, but we need to do the build server to be able to do this automatically, so that other people in my team, if they check out the code, they know they've got high quality code. So how do we do this? Well, all we got to do is go back to that repo that I was just working on, and I can go to MLOps Starter Kit, and we can just go here, right? This is a build server. It's built into GitHub. It happened, I think, in the last year or two. They built this out, and we just click on it. And a couple things to point out about GitHub Actions is that you can set up your own workflow by which we'll do, or you can also look through some examples here of how to deploy your code on Azure, how to deploy it to Ali Cloud, how to deploy it to ECS, how to deploy it to Google Cloud, Google Kubernetes Engine, IBM, OpenShift, Tencent, Terraform. I mean, there's just an unlimited amount of, integrations and documentations here. So really a lot of great documentation around GitHub Actions. And again, what is GitHub Actions? It's a build server. So let's go ahead and click this button, set up a workflow. By default, the key components to be aware of here is that it has the ability to listen to a branch, and you could tell it to listen to other branches other than just the default branch, and then it does something, right? In this case, this is just hello world, but what we want to do is kind of tweak this a little bit so that it actually tests it does everything I did locally. So what I can do is I can actually open up a new tab here, and let's go to that PyTest project real quick. Here we go. GitHub Actions PyTest, and notice I had a GitHub Actions workflow. I like this approach, which is you just copy some stuff you did earlier, and let's go ahead and paste this in. And if we go to this, there we go, we can see that it's a pretty straightforward process. Let's kind of make this all on one page. That, there's a Python application test with GitHub Actions, so this is our build server. Every time I push changes to GitHub, it will run this, and it will run it on the Ubuntu latest Docker container. and it will set up Python 3.8. And so it's gonna run Python 3.8 version. If I wanted to test other versions, I actually can test simultaneously Python 3.7, 3.6, 3. I could test a matrix of different Python applications. But notice here what I can do is I can test the installation works properly. I can test that the linting works properly. I can test that the actual application logic works properly. And then I can actually go through here and then format my code. And so this is really awesome because it gives me the ability to go through here and really have a uniform level of quality. So let's go ahead and start this commit. And there we go. We'll say creating a build process. There we go. We'll commit this. And then if I click on actions here, we can see it in action, right? It's actually going through here, and it's going to take a second here. Let's just refresh. There we go. And it's going to step by step do everything I told it to do, right? So really a build process is just the automation of what I was already doing manually, right? I just did manually make install. I just did manually make lint. I just did manually make test. I just did manually make format. Now I'm actually automating this and institutionalizing that knowledge as an automation script. And it can't be said enough how important this is as a foundational component to all software engineering and also MLOps. So I'm going to go through here and create a status badge. We'll go ahead and copy the status badge. And then again, going back here, we've got this, we've got this, we've got this. We've fully completed continuous integration, right? That's really the components of continuous integration. So I'm going to copy the status badge here. I'm going to go to code, and I'm going to go back to this project, which is MLOps Starter Kit. And I'm going to put this badge at the README, and this allows other people to get visual confirmation, right? You can see this visual confirmation that, in fact, yes, my project works. You should be able to check it out, and things are in a good state. So this is really the foundational component, continuous integration, to doing anything useful in DevOps or MLOps. Again, we can potentially also do the same exact operation on other cloud environments. So yeah, we were working on this MLOps Starter Kit repo. You can see the links here. We've got the full thing working end to end, which is great. And so now what I wanted to do is kind of keep moving here and actually show how it would work with the AWS platform as well. And then I'll get back into some theory here. So the final step, now that we've got this whole thing working, is to be aware that we also can run this in a cloud environment. And in my opinion, is that if you're going to deploy to the cloud environment, you should develop in the cloud environment. And there's a couple different options for this, and I'll show you both. So option one would be the Cloud Shell. I'm going to click on this. And if you click on Cloud Shell, what's kind of neat about the AWS Cloud Shell is that it literally is just a terminal. And if you have terminal skills like Vim and like Bash, you can actually kind of get right into production here and start building stuff out. And so for many scenarios, the AWS Cloud Shell environment, I think, is a great environment to use to do continuous integration, testing, any kind of deep integration with the cloud platform, because it has the SDK installed directly into this cloud environment. So really an ideal scenario here to get started with doing cloud computing. So let's just wait for a second here and get this working. Okay, so it's preparing our terminal, we're ready. Okay, so a few things to be aware of here is that let's look at the bash RC file. So this would be where I would configure my environment, and notice that I actually have a virtual environment here that I created that's local, and I used Python 3-m venv, and I created a virtual environment. So what's kind of nice is if I use this environment all the time, and I mostly am working on like maybe like a common project, I don't really have to do anything. It's ready to go, right? And so if I just quit out of here, that you can see that I say which Python 3, and it's actually in a virtual environment. So that's kind of neat. And what we can do next here is clone this repo. So I'm going to go back here, click on code, and then I'm going to copy this and then go to the Cloud Shell. And let's move it a little bit closer so I don't forget it. Here we go. We'll say git clone. Now I've got this thing added. Notice I had already set up SSH keys, and so I don't have to set up SSH keys to GitHub for this particular environment. And then I can do an ls, and I can see the Python MLOps cookbook. Great, and that's one option. There's a previous project, or I can go into the MLOps Starter Kit, which was what we were just working on. And then if I say make all, it should be able to go inside of here and just validate everything that we think is working does work. And in fact, we did. We validated that the linting works, the testing works, everything works. And in fact, I can even run that hello world code, right? And let's say Python hello. There we go. 2 and 2 is 4. And if I want to edit it, I can use the VI editor just like this, right? So there's a lot to like about this this Cloud Shell environment. It also comes with AWS commands. So like if I wanted to look inside of a bucket, see all my buckets on my operating system, or I'm sorry, in my cloud environment, it would actually show me all that stuff. So it's a pretty neat environment to develop in, especially for quick and dirty things that I'm working on. But I think the even more rich environment is probably going to be Cloud9, which we'll get into quite a bit today. So I'm going to click on Cloud9 here, and we'll just start from 0, and I'm going to create a new environment, and we'll call this MLOps Starter, and we'll say next step. My recommendation when you're working with Cloud9 is that just leave everything default, because it'll do the right thing for you. It'll pick Amazon Linux. It'll time out after 30 minutes. It'll use a micro instance, which is totally fine. Now, if you are an advanced user and you're doing some kind of really big data processing or parallel computing or something like that, sure, go ahead and use a bigger one. But once you've gone through here and set this up, again, this will take just a second. The first thing that we would do would be to create some SSH keys, verify that works, and we've got our starter kit working. And this will kind of close out the full continuous integration in the cloud environment that I was talking about earlier. So basically what we're doing here is we're just closing the loop on we did this, and then the development environment, we knocked out code spaces, and we also are going to knock out Cloud9. And then we're going to move on to, after that, we're going to move on to getting a little bit more into these microservices and business logic. So let's go back here real quick in Cloud9. This should just take a second. And a couple things I'll point out about Cloud9 while this is loading that are really awesome is that if you notice, it's a little bit grayed out right now, but up here, this is where you can share and do pair programming with other people. So this is really helpful. We're in the world now where I don't think many people are going to be going back to the office as potentially they thought. I think many people are going to be working remote. And so tools that allow you to do remote pair programming are going to be very popular. And here's a good example of a tool that's pretty cool, right? I just say share, I add some people, and they can start pair programming with me. Also, it does have a debugger. I think someone asked that earlier, right? You can see here it's got a full debugger. It also has the ability to do source control integration, which is pretty cool. It has the ability to talk to AWS. So if I click here, look, it can talk to API Gateway, which are like REST endpoints. It can talk to automation code, infrastructure as code. It can talk to logs, so we can look at logs for different applications. We can look at container, right? So ECR, which is Amazon's container registry, we can look at things inside of there. And then also we can look at serverless technology and S3. So really there's a lot of deep integration here, and that's why I would recommend people use a cloud-based environment to develop their code if they're going to deploy in that cloud-based environment. So all we really need to do to work with this MLOps Starter Kit here is just do SSH keygen -t RSA. So make an SSH key to give it to GitHub. You only have to do this one time and you never have to do it again for a particular environment. We'll go ahead and print this out by using the cat command. Copy this and put it into our GitHub. So let's go over here. Let's go to this settings, go to SSH and GPG keys, make a new one. We'll call this MLOps. MLOps, boy, it loves substituting there. MLOps Starter Kit, Cloud9. Add the key. Perfect. All right, so we're all good. We got this thing cooking here. And now if I go to a git clone, so let me just go back a couple here. We can clone this repo, click on this, copy this, and do git clone. Say yes, perfect, cd into. Now, I think it would be good to go here. When you click on environment, it shows you the directory layout, so we can see the code here. And so if I cd into this MLOps Starter Kit, I can do the same thing. I can run make all. And we can see what the make file does, right? Which is, it just runs the install, it runs the lint. Now, notice that this one says it couldn't find Python black. And so this is because I didn't use a Python virtual environment. And so that's a no-no, right? So what I need to do is create one real quick. And that is a perfect example of why you want a Python virtual environment. So we're going to say Python 3-m venv. Let's go ahead and make one because it's non-deterministic. You have no idea what's going to happen if you don't use one. And then we go and we create this. Okay, activate. And now we can do make all. And this should install everything and we should be good to go. Okay, there we go. So we got the whole loop working. So let's kind of go back to theory mode here. So as I mentioned before, we need this hierarchy of needs here, like Maslow's hierarchy. And so with machine learning, this is really what we just set up. We set up DevOps, and so that's one of the key components here. And in fact, it's a Python scaffold, right? And this is my recommendation: is if you do something like this every single time, you'll have a great experience and you'll make the DevOps portion of MLOps very easy. The make file is really a recipe. We talked about that. Make install, make lint, make test. And then another thing to be aware of is that if we kind of scroll down here, is that these code space type environments are really a great way to be extremely productive. GitHub Actions, we just went through that. It's a very easy way to do the build process. And then in terms of continuous delivery, this is really the main takeaway, is that by doing continuous delivery, you're able to have a branch-based approach where you can put your code into an n number of environments. So behind the scenes, every time you do a new project, you're deploying a new version of your code in the cloud. And so now let's get into data ops and data engineering a little bit. We were talking about that earlier. Really the idea here is to automate the flow of data. Just like, how can you have a city if you don't have clean water? You know, how could you possibly have a dishwasher if the water doesn't come into your house through the pipes, right? You need to have some kind of foundational component for data in order to do MLOps. And so here again is a kind of a picture of really high level a data collection job where you have everything inside of a data lake here, and the models are inside of here. You can do big data processing, so you could spin up 40 machines. And because the data lake is infinitely scalable, right? And that's really the advantage of using something like Amazon S3, is that it doesn't matter what you throw at it, you can put everything inside. Now notice, I think someone asked about this earlier as well, data feature store, that the feature store could be really putting everything in a processed way so that it's ready to do machine learning. So this is really data ops, right? Is you have the ability to do all these things: model versioning, big data processing, serverless data engineering. You have feature stores, you have the periodic collection of jobs, and you have infinite scalability, right? Those are the components of data ops. Now for platform automation, I think I mentioned this earlier here. I think the big takeaway, and let's just maybe expand this a little bit here, is that it's really easy to be dismissive of platforms, and especially say, oh, well, we hate the cloud, they're bad, or whatever reasons people don't like cloud computing. But the reality is, then that's fine. If you're Tesla, for example, and you're building your own autonomous driving systems, then you may have the expertise to build this, right? Okay, do it, build your own thing. Many companies don't have the expertise or the willpower to do this because it really doesn't fit with what they're trying to solve. But in just a regular project here, just imagine how much stuff you have to orchestrate. The notebook goes through here and it launches like a k-means clustering job, which also behind the scenes launches a bunch of nodes, and then it serializes the model to the disk. And then that model, once it's on disk in the cloud storage system, will then get pulled in from another endpoint, which is elastically does predictions. Likewise, maybe you have a second machine learning job that goes through here and saves the model. The training itself, data is living in S3 bucket. So you have a whole bunch of different things here that you're going to need to orchestrate when you're doing machine learning at scale. And so I think this is really an example of why a platform is going to help you out a lot. And I'm not necessarily saying one platform is better than the other. If you're on the cloud, I think that's a good place to start. There's even third-party platforms that can help you out in doing all this kind of orchestration. So again, this is really the concept: is you want to start deploy versioning. You got to have the DevOps. You want to audit things. You want to monitor what's happening. Is the model performing correctly? Also, is there data drift? Do you have a bunch of changes in your data? Okay, let's go ahead and retrain the model. And that's really the pipeline here. I also mentioned this earlier, that machine learning platform, the idea here is that you can deploy to many different solutions. And that's one of the key takeaways. And you'll see this with the Vertex AI platform from Google. When you do AutoML, it'll actually give you the capability of picking different kinds of exports. So you could export via TF-Lite, TensorFlow, JavaScript, CoreML, Core Container, or Coral. So that's kind of it in a nutshell, right? The 25. So let's go to the next chapter here, which is the foundations. And this kind of gets into some of the things that I was talking to earlier. So how do we, now that we know that DevOps is important, we went through and showed the DevOps stuff, how do we get the foundation for MLOps in an organization? So I think a few things to be aware of is that it is important to know Bash and Linux here. And in particular, it's going to be these Cloud Shell development environments. And that's why, if we go back here, this is so important, this Cloud Shell environment, because it allows you to interact with data. So you can copy data, like if I said AWS S3 CP, I could copy huge quantities of data back and forth. I could actually interact with, let's say, Lambda, and I could invoke the Lambda remotely. I've got the hooks to do a bunch of things by using the cloud platform. And again, you can see here, this is a good example of the Cloud Shell environment. I think if you are going to be heavily using it, it's a very good idea to work with the Bash RC and start to customize your environment. So it also means you may want to get a little bit of experience with the Vim editor and just know enough to kind of work with a file, edit it, open it up, save it. And then now a second option on AWS is this Cloud Shell environment. Here you can see an example of a project I was working on earlier where I was able to invoke something that talks to S3 and play around with it. And because, again, if we go back to our Cloud 9 environment here, it's got this deep integration with all these services, S3, Lambda, etc., that it's very easy for me to interact with that environment. So in a sense, it's like if I want a watch that talks to a phone, well, if you use an Apple Watch and an Apple phone, they're going to talk very well to each other. It's theoretically possible to get a non-brand, like an Android watch with an Apple phone and have some kind of communication, but it's much more difficult when you use the integration that comes with the platform that you're working on. Like in this case, Cloud 9, you're going to have an easier process of getting started. So that's again, my recommendation would be to use these cloud native environments. So a few things to be aware of, obviously with the shell, listing files is a good thing to be aware of. Knowing where commands run. So the which command, for example, I've used quite a bit. Also to pipe things in and out of one program to another. So this is example ls-l, wc-l. So it says basically show me a word count of the lines that get found out. Printing working directory is a good one to know about. This shows you where you're at. CD into a working directory, that shows you the new directory you're in. And then also the ability to kind of send things in and out via command line can be really helpful. And in particular, why would I care about this? Here's a good example that you can run the shuffle command here. So I think I can maybe even download this. Let's go ahead and see if I can download this. So if I go to the Cloud Shell and I type in wget, which I don't even know if it's installed. Looks like it is. You can see that this file here is pretty big, and I could do a -h to make it human readable. So it's a pretty big file here, 128K. And so if you notice in this example, what I say is that you can actually shuffle this file and put it into a smaller file. So what this does, this command here, we'll go back to this. If I run this, paste it, that it says time it, and then basically pick the first 100,000 rows and randomly select them and then make it into a smaller file. So if we do that, you can see it was very quick. And then if I do ls-lah, you can see that new file is the same size because they're both 10,000. So I can make it smaller. So let's go ahead and make this 10,000 now. And then if we go through and we do this, we can see that that's actually still a pretty small file. So maybe that file is, maybe let's make it 100. Let's make it tiny. Let's call this 100 sample. We'll just pick 100 things from this thing. There we go. And now if I do ls-lh, and if we look at 100, you can see, okay, this is much smaller file. So the idea here is that by using this shuffle command, I can actually sample files. And why would you care about this? In many cases, before you get into some huge data file that you want to put into a machine learning job somewhere, you may want to just make sure it's even feasible to work on the problem. Like, are the columns okay? Is it a clean data set? And so, being able to do some basic shell commands can really be helpful. I think I mentioned about this earlier that the bash RC or zshrc, if you're using Z shell, are really killer commands to be aware of. And the more you automate those config files, the easier it is to get working. Also, pretty simple to build bash scripts. So again, you can build a bash script that could automatically truncate files for you by just using the chmod command, for example, and then putting some things in there to make it executable. But yeah, in a nutshell, that's really the gist of what I would call a foundational component. Another thing to be aware of as well is to be aware that the cloud really is a building block. And for data engineering, machine learning engineering, you're gonna need to be in an environment here where you've got the ability to do compute storage that's near infinite, right, without moving the data. And that's a key takeaway, is that in theory, I guess if you had enough storage, you bought enough hard disks or something, you could put them all on the network somewhere and then copy the data back and forth all the time. But really, that could be extremely wasteful, because you'd be spending all this time processing the data over and over and over again, or I'm sorry, moving the data around. Instead, if it's all in the same location, you can process it without moving. And that's why things like SageMaker even work, is that you can process directly inside of this environment without needing to worry about other things that you're doing. AutoML, I think, is another one to point out that can be really helpful, in that it can help you automate things. But let's just really briefly talk about the cloud computing. We've just started to touch on a little bit, but one of the big takeaways is that, again, typically the scenario is that you have GitHub, you have some kind of, or whatever source control system, you have some kind of build server, and then you have some kind of Cloud Shell environment, and all the clouds have them, and even GitHub has it. And the idea here is that this is the workflow that you're going to be spending a lot of your time on in terms of a development environment. And what is interesting is that what you'll notice is once you've got, let's say, one working, like what we have right now, we have AWS, it's pretty straightforward to get similar things working in either the cloud platforms, because they have similar concepts. Python, we can kind of skip past this, but one thing I will point out about Python that's important is that Python does have some real bad performance problems, and it is important to know about that. And so really the takeaway here is that you should be using libraries that make all this faster, right? In general, try not to build things in Python, build on top of things in Python. So for example, serverless computing is probably built in Java or Go, and then you build on top of that. You don't try to build serverless computing in Python. Also, I know many people are concerned about global warming. That's another thing to be aware of, is that Python is actually a very bad language in terms of energy efficiency. It's actually near the bottom here. And so again, a reason to minimize how you use Python. If the cloud does majority of the work for you, then Python is just orchestrating things. But you don't necessarily want to be building high performance servers in Python. So we can just kind of go through, skip past this Python stuff, but let's go into the basics of descriptive statistics and distributions here. So one of the things to be aware of is that it is important to have a basic understanding of descriptive statistics and normal distributions, and a good one is height and weight. That in a normally distributed data set, you'll see that there's like a bell-shaped curve. So here's 25,000 height and weights here, and if I plot it, you can see here that basically everything, this is the regression line here in the middle, is that really there's a linear relationship between the weight in the pounds, weight in pounds and the height. And if I describe this, I can see the 50th percentile, and there isn't, which is the middle, and there isn't a huge variation between even the percentiles here. And that's visible by doing a bell-shaped plot here, or a normal distribution plot, where you see that the most of the values for height or weight are in the middle, right? And so this is just a concept to be aware of, that now not all distributions are normally shaped here, but if they are, this is something to be aware of, that it is kind of a helpful concept. There is an example of distributions that are not normally shaped, and that's the famous Black Swan book by Taleb, where he talks about fat tails, and it's important to be aware that those exist as well. Another core component of machine learning is this concept of optimization, and really the core intuition behind it is that you're basically walking down a mountain, and you have to figure out the best way to go down the mountain. If you're too close to the ground, you might get stuck in a local minimum. If you're too aggressive, you might just fall off the mountain. And so a good example of this, if I go through here, is I think I have a picture of this. If we scroll down, that optimization here, we have local minimum right here and global minimum. So again, if you're kind of going through and walking down a mountain, you could get stuck in a local minimum, but you want to get to the bottom so you can go home safely. That would be the global minimum. And so a good place to play around with this, if you haven't had a chance to work with the gradient descent function, is this TensorFlow playground. If we go here, this TensorFlow playground here, it shows you the ability to simulate over and over again the training environments. And in particular, what's kind of cool about this is that you can actually just click this button and start to see like what happens when you train different kinds of data sets, right? And you can even see like if I add hidden layers, what happens if I change the learning rate. Like, if you put the learning rate really high, for example, things start to thrash and they don't go anywhere. So all of these concepts of intuition around deep learning, you can play around with them intuitively using this tool. So I think that's a great tool to use to be aware of deep learning. As I mentioned, that tool, TensorFlow, is a great tool to play around with in terms of understanding the intuition. Finally, I think just mathematically to look at solving things here, that if the learning rate is too high, then you're going to thrash, right? And that's what we saw with the TensorFlow tool. If the learning rate is optimal, you'll get a great solution. You'll go to the global minimum. If it's too low, it'll take forever to train. So that's one of the problems to solve that cloud computing does have some role in that if you want to get an optimal learning rate, you potentially would also need to have good hardware that could take advantage of that learning rate. But if you pick something too high, again, it'll just kind of thrash back and forth. And that's why also the automated platforms might be something that can help you pick the automated learning rate. So key concepts with ML, we've got in general 3 categories. Supervised, which means you have labeled data that you know what you want to predict. So for example, stock prices, that would be a good example. Unsupervised means that you don't know what the right labels are, but you want to use techniques like clustering to automatically figure out what those are. And then reinforcement learning would be when you're going to train a car to drive around, and then you want to, again, like with self-driving cars, you want to train it to do the right thing over and over again. So let's take a look at example here of a clustering algorithm. This is a bunch of different clusters. We've got points, we've got rebounds, we've got assists, we've got blocks. The assists here are large, right, where you kind of got these big bubbles. That's one dimension. The blocks are, the redder it is, the more blocks you do. And then in terms of the points, the farther you are to the right, the more points. So what we can see from this is that by clustering, we're able to actually put things into different roles very easily, and the machine was able to discover things like, for example, these are all really large players, right? Because the large players make blocks, and then these players were the best players. Likewise, the point guards have a lot of assists, right? So that's one of the cool things about doing clustering, is it is able to automatically tease out this information for you. And so another big thing to point out with clustering is that you need to figure out the correct number of assignments. And so that can be done as well automatically with things like SageMaker, which can do the automatic hyperparameter tuning, which again is an MLOps best practice. Is why do all this yourself if you can just automatically pick the hyperparameters from a tool. Another thing to be aware of is in the cloud, actually a great way to get hands-on experience with reinforcement learning is to use the deep racer system that allows you to train a model around a track. And so this is a good example of this, where we have an agent, there's state, there's a reward, there's an environment, there's an action. And in fact, let's actually take a look at this real quick. If we go back to AWS, this is a little bit of a feature that I think is hidden, or most people don't experiment with. But Deep Racer, what's really awesome about it is that it has a pretty simple workflow to get started with it. And if you want to know more about reinforcement learning, click on Deep Racer, go to Get Started, and you can see here that these are the components to building reinforcement learning on AWS. So first, you learn the basics, then you create a model, and you choose the action space, the algorithm, the reward. You train and evaluate your model. You iterate and upskill. So this is MLOps, right? I mean, that's what's kind of cool about the SageMaker or the Deep Racer platforms, is they give you a full MLOps workflow where you're actually getting everything done at a high level. So the first place that I would recommend playing around with is to start this really quick 10-minute course. Let's go ahead and do it together. So basically, what is reinforcement learning? You can see here that there's it's a type of machine learning, right? And so it's an agent and an environment. You see this with RoboVax. Those are a good example of reinforcement learning. But the idea is that you're going to reward something based on its actions. And supervised would be you know the labels. Unsupervised, you don't know, and you're discovering things. So how does Deep Racer learn to drive? Well, the agent interacts with the environment and it gets a reward, and you're trying to maximize the number of rewards. So you can almost think of this a little bit like a kid or a pet, where rewarding a kid if they do the right thing, or a pet if they do the right thing. And so the agent is, in this case, actually the driver, right? And so this one is it is a neural network that controls the vehicle, taking inputs and deciding. The environment is the track, right? So this is where all the different things go on. And the state is like, where is it at on the track, right? Is it on, a little bit going to the left, or is it, third of the way through? Where is it at? And so how does it learn to drive? Well, it takes actions based on the current state. And then the reward, again, is the feedback that you give. And so you build a reward function. So in a nutshell, how do you train a reinforcement learning model? This is a great visualization here, is that the most simplified approach would be if you can figure out how to get it to go straight, right? Like that would be the optimal route, right? This would be suboptimal over in the black here. And so each of these is a different state. And so what you could do is you could reward that every time it goes through this square, that you would give it 2, and that would be maximizing the optimal path. And if it goes off a little bit here, you would give it a lower reward, like 1/10 of the reward. And then if it goes over here, it gets 0 reward. And so this is the idea here on training a reinforcement learning model. And then an episode would be you go through and you have a training run, right? So next here, we would go through here and we would go to this next iteration, and you basically keep trying to figure out the optimal path by maximizing the reward. And so over time, eventually you would get something that would have a pretty good result, and you would have the ability to make a successful run through the track. So eventually, if you do this enough, you would actually get to a converge on the best solution. So part of it, though, is that you have to discover what the best solution is, and that's the exploitation. And then the convergence is, okay, let's now pick the right strategy, which eventually would be this, right? This would be the correct strategy. So, what are the parameters of a reward function? These are all things in this particular example. They're going to be different for different examples, like a Tesla self-driving car, right? They would have different examples. But for this, it's a constrained environment. You'd have position on track, the heading, the waypoints, the track width, the distance from the center line, all wheels on the track, speed, steering angle, right? These are all things that you could reward. And so you can see here, as you go through the track, there's X, Y coordinates, there's headings, right, that figure out where you're going. There's waypoints, like what segment of the track are you on? There's the track width, right? So how far are you from the distance line? Are the wheels on the track? Is there speed? Is there steering angle, right? In the summary is that there's these 13 parameters here that you're going to use to your reward function. And so each of these are all going to be something that you could actually use in training the model. And then finally, what's nice about this particular framework that the AWS platform gives you is that it's just a Python function. And you can see it's really simple, right? Is I just go through here and I return back the reward. That's it. So I can just look inside my environment and figure out, where I'm at, and then say, okay, here's the reward I want to give based on what the state is that I'm currently at on the track. And so there's a bunch of different analogies here, or strategies. So follow the center line, prevent zigzag. Here's another example, but in general, that's really the concept. And so I would recommend, if you want to know more about like autonomous driving, go through here, create a model, and you can train it out yourself. So really actually a fun thing to play around with to give you more experience with real world MLOps. And in fact, I believe the Deep Racer workflow does have a limited capability in the free tier as well. So you can actually run through this and experiment with it. So let's keep moving here. That's the high level, which I basically talked about. Another thing to be aware of as well that I think comes up a lot with MLOps is that just because you're doing a lot of machine learning engineering doesn't mean you get to throw away data science. And so what I would recommend when you're doing data science is to have these 4 different types of things: ingestion, exploratory data analysis, modeling, and conclusion in your project, and check that in potentially to your GitHub repo. So here's an example of a data science with COVID notebook that I did, where we have the ingestion, where I ingest the data, exploratory data analysis, modeling, and conclusion. Now, I guess in this case, in some circles, data science and COVID is non sequitur, right? Because people are doing all kinds of weird things like taking, horse dewormers. but it generally for science, you would have this approach where you pull in data, you look at the data, you look at the exploratory data analysis, you look at patterns, you do predictions, and you make a conclusion here. And I think this is important to check in alongside what you're actually working on, so that people can. That's another, someone asked about auditing. That's another way to audit the artifacts of what you're doing, is you give someone the explanation for why you decided to create this model that's in production. So it's almost like a manual for the car. Like, the car is driving, all this stuff, and you might want to go back and look at the manual and go, hey, wait a second, well, why are we doing this, or why are we doing this? Why not just check in a notebook inside of here? So let's even take a look at this notebook. And so here's an example of a data science notebook. Notice how I checked it into a repo, and which is pretty cool with Colab, and it would fit alongside my project. So I can click on this and open this up. In fact, I can actually even share this out. Let's go ahead and share this thing out here. So if you wanted to experiment more about COVID and start to figure out on your own, what the lay of the land is, this is a great way to do it. We see this table of contents, right? And I can see the different sections in ingestion, EDA, modeling, conclusion. I really think Colab notebooks are pretty awesome, because again, they're so easily integrated with GitHub and other people can use them. And so I can immediately start playing around with the ingestion of the data here. I can just click on this and notice that it'll give me the ability to import pandas, make a data frame, and I can actually even put who I got the data from. So in this case, it's New York Times, and we can see all the latest data. Now, another thing to point out is I also can go here and I can say run all, and it'll actually just execute every single cell, which can be pretty cool, because I can then now look at the cell and look at the latest data. And right, if I scroll down, maybe I want to look at like the latest plots here, and we can see that, maybe we're starting to get out of the woods a little bit here, where the deaths are starting to taper off, right? And if we look at the date-based, things with COVID, you can see that there was a huge spike initially with deaths, and then now kind of it spiked again, and then maybe things are going down. So maybe we're starting to get out of the woods here a little bit. And we can even look at states, right? I can scroll through here and I can look at the different states. Okay, who are the states where different things are happening? California, They kind of limited it for a while. They had that severe lockdown. Then we go into a dip, and then it came back again, and then now it's kind of being flattened again, right? And it's kind of neat to be able to look at a visualization that shows this. Now we look at Texas, which is a little more of a free rolling state. Maybe things are starting to go a little bit more up versus California. These are all things as a data scientist you could evaluate. Again, you can do plots like this that have interactive plots. There's all kinds of ways to visualize this data. In a nutshell, this is what I would do if I was building an MLOps pipeline, is I would also do some traditional data science and kind of keep it here so that other people can look at the intuitions for what I'm trying to do. It's one thing to just say something, which I think is one of the problems with social media, is people just say things and there's no way to actually validate whether what they said is true or not. But that's basically the opposite of data science, right? Data science is not saying something, it's actually proving it by actually showing step by step the data, how you came to the result, and actually explaining the prediction and explaining all of the different aspects of what it is you're building. So it's critical thinking in a nutshell. And I think it is important to include this critical thinking into your machine learning project. So I'll kind of scroll down here. So if you are going to now take all the stuff we talked about and build an ML pipeline from zero, I think a good way to think about this would be that you have GitHub, you have a change event, you have some kind of DevOps system, build system. In this case, Microsoft Azure has something called Azure Pipelines. Google has something called Cloud Build. AWS has something called Code Build. Whatever, use one of the cloud native platforms. Also, this is the deployment environment. So Azure App Services is a good example. And you could deploy this Flask machine learning API. So in a nutshell, the idea here is that you create a virtual environment, source it, do the make install step like I just talked about. And then separately, you could actually go through and maybe make a prediction. And here's an example in Azure that I again use their Cloud Shell because it's a great place to start out with kind of getting the whole end-to-end pipeline working. I then go through here and I say, okay, let's wake up the GitHub repo with Azure Pipelines and get that thing cooking. I clone it inside of that environment. I say make install. And this particular command here it's very similar, in fact, on all cloud platforms. Is we were showing earlier AWS, but in this case, this would be Azure, like AZ web app up, right? And I would just say, hey, launch a serverless environment so I can use it for my application. And then finally, I go through here and I verify that this deployed application works by browsing to it, right? And so this concept is very, very similar in many cloud platforms where you have a platform as a service and you interact with your build process. And then finally, you would go through here and verify that the machine learning prediction works, right? So that's really in a nutshell, and these are the kind of the steps here to go through and prototype that out. So in a nutshell, though, this concept is very, very similar across all platforms. So what we can do now that we've got this starter kit kind of working here is that I'm going to go to another project that I have, and we'll kind of shift gears here and go to Python MLOps cookbook. And let's take a look at this cookbook, and I'll give this to everybody. So this cookbook, what I think is kind of cool about it is that if we scroll down here, this is an intentionally simple educational type project. It isn't necessarily real world. It's intentionally made very simple so that you can understand some of the core concepts of MLOps. So I have a make file, which we already went through. I have a requirements file, which we already went through. And then I built some command line tools to allow me to interact with a model. I also have a utility here that I can do things like retrain the model. I have an application that is my microservice. I also have a model handling library, and I also have a CSV file. And then in this port, I have a serialized model, and then this is a Docker file. And then, as I mentioned before, I like to also put a notebook inside. So really this is kind of what we want to get to towards the end of what we're doing today, which would be a kind of end-to-end loop here of a machine learning model. And so I think a good transitionary step though would be to talk about the microservices, right? Because if we go back here, we've kind of nailed this. We've nailed the build server. We've nailed the development environment. What we haven't necessarily gone into per se yet are the deployment environments and the microservice. And then finally, when we wrap up, we'll get into business logic. So let's get a little bit into these two components of MLOps and continuous delivery, which is the deployment target and the microservice. So what I'm going to show you is, let's actually open up another window here, is something I just built a couple days ago, and it's called FastAPI. And this is really like a sample, and let's throw this in here. This is just a sample project that's intentionally very simple, that shows how you could use FastAPI. And we see that our usual suspects are here, right? We have a make file, right, a requirements file. And so what I'm going to show you real quick here is how straightforward this actual application is. Notice that I use this FastAPI service. I use their web service called UVcorn. And then I have a hello world. Here's an example of it. And then in this particular example, I actually add two numbers together. So kind of similar to what I covered earlier with the scaffolding. And then I tell it to run on port 8080 and also on host 0000. So what we can do is let's go here and let's click on code. And I'm going to copy this SSH key or SSH URL, go back to this environment, and I'm going to cd up one level, and I'm going to say git clone, just like this. And this will give us access to FastAPI. If I change inside of here, we can do the same thing I typically do, which is make all. Let's go ahead and try that out. Okay, in this environment, I haven't made a test file yet, so who cares? We can skip that step. We don't really care about that right now. In fact, I can even change the make file so that it doesn't do that, right? We can be lazy, and we can just say, nope, we don't want to test right now. So let's go ahead and say git status, git add make file, git status. Git commit, adding change. Not sure why this thing is acting a little bit weird, but anyway, in a nutshell, I've maybe changed the wrong file. That's why. I think it's this one. There we go. We want to save that one. Git status. Let's try that. Git pull. Okay. Anyway, it's if I say make all, it won't give us this error anymore. But in a nutshell, what I do want to do is, let's see, make install make lint. Oh, I'm in the wrong one. That's why. I knew there was something wrong here. Okay, here we go. So let's change the make all. Let's grab this test out. Okay, there we go. Now if I do git status, there we go, git add make file. So let's just remove that out of there to get rid of that error. Adding or removing test. There we go. And we can fix all that later. So we remove the test, but let's now run this application. If we look at it, we can see right here that it's just got a hello world, and it's able to add two numbers because we have two parameters here like this. So I'm going to go ahead and say Python main. There we go. So we see it's running on port 8080. And in fact, I can open up a new shell by clicking this plus icon, new terminal. And then I can actually just do a curl of localhost 80, 80. There we go, right? And so if I want to actually add those two numbers together, I can do this. There we go, 2. I can do 4 and 4. Now that's pretty cool, right? That's actually definitely a neat little service to be aware of, that you can do all those tricks. But one of the really killer features of something like FastAPI, and why it's so popular with MLOps, is that it also has built-in Swagger documentation. So in order to show that, I'm going to have to be a little bit tricky here. And what I'm going to do is I'm going to go to EC2, and I'm going to wake up the port that allows us to communicate with Cloud9. So we see Cloud9 is right here, right? Here's our instance. So we know that it's going to be available via this address. This is a publicly available address. So I'm going to open up a new tab here. I'm going to scroll this over, throw this. And so when it's available, it's not going to be available right now. It's going to hang there for a second. It's going to be 3.8.39.86. So what we can do is we can actually go to the security groups here, and we can actually let it have an inbound route to that location. So in order to do that, we're going to go to the security groups, and we're going to let's make sure we're picking the right instance here real quick. So it's going to be instance ID, it's going to be security group, this one. We're going to click on this security group. There we go. And we're going to edit the inbound rule. So we're going to edit it, and we're going to say we want port 8080. We want the whole world to be able to browse our web service. There we go. And now if I go back here, what'll happen is, there we go. So we got this. I can now interact with this web service, and I can also do the add, and I can do 1 and 1 is 2, right? So that is pretty cool, right? That I can do all this, but even further, I can actually use the docs method, and if I do docs, it gives me the full Swagger API. And then once I've got the full Swagger API, I can click on a route, and I can say try it out, and then I can actually start doing 5 and 5, right? And I can execute and start playing around with the results. And even further, it even gives me the curl command that I just implemented, right? So I can copy this, go back to my terminal here, and even just paste it in, right? And then execute it, right? So this is one of the really awesome features of the FastAPI system, is this deep production level quality that they give you by giving you this Swagger API. And that's why I think a lot of people are so fascinated with this FastAPI, and they're building a lot of machine learning applications with it. So what can we do next here? I'm going to stop this service since we don't need to do it anymore. Let's go ahead and kill this. And so how would we now get this code? And then, as I talked about earlier, we played around with this, we got this working, but how do we get this? How do we get the deployment environment working? I think one of the easiest ones on AWS would be to use the AWS App Runner service. And so what we're going to do is we're going to go to that App Runner service, and we're going to select it here. You could also search for it, but let's click on AWS App Runner. And what's awesome about it is I can just do this. I can say, okay, create a service. And there's 2 flavors to AWS App Runner. Flavor 1 would be a container registry. So you would go through here and you would say, I want to create a container, check it into this repo, and then I'm going to use it from the container repo. That's one option. The second option is you just click on source repository, and you can actually pull it directly from a repo. So they're both great methods. Actually, we'll show both. So let's pick on source control repo first. I'm going to, I've already hooked up integration to GitHub. So all I need to do is go down here to the FastAPI. There we go, FastAPI. And I'm going to tell it which branch. So if I was doing continuous delivery, right, I could have a main branch, a staging branch, a production branch, any amount of branches I want. And then I'm going to have to pick an option. Do I want to do manual or do I want to do automatic? Now for production, eventually you'd want to do automatic, right? Every time you make a change to the source control repo, it'll automatically pull the new changes and deploy it. Initially, my recommendation is when you're first playing around with this service, I would go for manual so that you can have control over your automation aspect. So we're going to go through here. We're going to go to manual. Now, there are a couple different flavors of this as well. You could use a config file, which is pretty cool because you don't need to do anything. You just put a YAML file in there that's got everything ready to go. Again, initially, my recommendation to play around with this service would be to first try it out to make it simpler by configuring your settings. So we're going to select what runtime. There's two that are available. One of the runtimes is Python 3. Another runtime is Node.js. We'll pick Python 3. And then we'll go through here and say pip install -r requirements.txt. And then all I need to do is also tell it how to execute, right, when it goes somewhere. And so we'll say Python main.py. That's it. That's all we got to do. So really, a lot of those kind of heavy lifting that I've already validated with the continuous integration process, tested in my development environment, I can now leverage those wins and know that the exact same runtime that I have for Cloud9 will be able to be used here. So I'm going to go ahead and say next. There we go. We'll call this a new service. We'll say like new FastAPI, O'Reilly or something like this. There we go. And then I could, if I wanted to as well, like do all kinds of really cool things like configure how many requests per second and how many instances and all kinds of really fun things, how long I should do health checks or even custom health checks for different endpoints. But let's use everything default here, say next, and then do a create and deploy. And that's it. And then what'll happen is that what's really cool about this is it'll give us an encrypted URL, high quality production environment where we can actually start making API calls. We can talk to the Swagger service. Really, it simplifies an incredible amount of the deployment process for us. Even further, we can look at the logs and look at what the application's doing. We can look at the configuration. So really, this is kind of the next generation of tools that are starting to become available. We can look at service metrics, custom domains, right? Where if I wanted to route it to my own private domain. I mean, really awesome, like end-to-end service here that you can use to build things quickly. So while that's building, actually, what I'm going to do is go to one I already built previously. So let's look at this one's already running. If I take a look at this URL here and I just click on it, there we go. You can see that this thing's already running here. And I believe, let's see if I go to port 8080, let's do colon. Oh no, it doesn't need port 8080 because I already did that. I'm going to say add 1 and 1. So I think this service may not be the right one. Let's pick this service. There we go. So this is Hello World. And I'm going to say, again, add 1 and 1. There we go. We got 2. And even further, I can check out the Swagger documentation here by just going to docs. And then I can actually invoke this API. I select this. I say try it out. And I just say, again, 5 and 5 should be 10. Right? So pretty cool that this is a production grade service all ready to go. And if this was a machine learning application that was exposed to the public or to developer partners or something like this, we're done. I mean, right? Really, we've got a secure URL, we've got automatic deployment, and we also have the ability for other developers to introspect this, right, and figure out exactly how to use it. In fact, I can copy this, go again back to my environment here, and let's invoke it. Right there we go. We can invoke this thing remotely by using that curl command. So really awesome production grade framework, and I think that's why a lot of people are using this for MLOps, because again, it's really kind of an ideal MLOps type framework because you can wrap up your logic, allow people to see how to interact with it. They can start to build services around your API. Really end-to-end solution that's really pretty cool. Now notice if we go back to this service, I think the one I'm playing with is this one right here, that if I click on it, it tells me the URL just like this, right? And so if I've already got automatic deployment set up, then we're good to go. But what I could do is if I click on this, I could look at the main file and say, okay, let's make a real small change. And let's do this hello world O'Reilly like this. And then I can save it, commit it. And then if I go back here, we can just click deploy and deploy it again. So this is kind of simulating the process of what it would be like if we had selected that option that said continuous deploy. I personally think this is a better way to first start and prototype things out because it's pretty easy. You just go through, click this deploy button. But eventually, as you start to build out a full end-to-end pipeline, you could actually, hook these up to different branches, automatically deploy this. And again, this is, you could have a one-person company that could build software as a service. And because the complexity is so low, it would be pretty straightforward to actually build something like this. So, after we kind of prototype all this, then the next thing that I'm going to show you is how we could then take the this cookbook and we could do the same thing with this cookbook. Now, this one is a Flask-based approach, which will show us a slightly different flavor. It's similar, but again, the idea here is that it's really trivial to kind of get this stuff cooking and build all this stuff out. Now, this one it does take a few minutes for this to do the change. Let's go ahead and take a look at this FastAPI here that I had set up initially, and even look at the log files, right? This is the first thing that I set up. Notice that it actually tells us every single aspect of what happened. So starting the source control, pulled it, the operation in progress, the services created. There we go, it's still running. So these are the event log. We can also look at the application log as well. And the application logs would show us if there was something in there, exactly what's happening. And when this is fully deployed, the service will be available. For the service that we had already used though, we should be able to see the logs and actually go to application logs. And this shows actually those requests that I was doing earlier, right? And so we can even look inside of CloudWatch logs here and actually go through here and build out, custom metric filters and all kinds of really cool stuff inside of here. But basically, it's got everything that a production-based environment would need in the real world. And in other experiences I've had as a CTO or individual contributor or engineering manager, we would have to build all these things out. But what's really powerful about this app runner is that it really kind of encapsulates all the best practices that you would want to use for a microservice. So again, this is essentially giving us, we did this, we nailed it. Went to the microservice, we kind of nailed how that works. And then we're in the deployment target. So we're really kind of cooking here, right? Where we're able to we've got this nailed, we've got this nailed, we've got this nailed, we've got this nailed. And really the only thing left here after the deployment environment is fully fleshed out is, okay, now let's hook up actual machine learning code and do all these same things to it. Fortunately, I already have a project set up here that has a lot of that built into it, and it should be easy to do that process. So let's check one more time here to see in type of app runner. Okay, look here, this redeployed. I think this just got changed. If I click it, there we go. Hello world O'Reilly. You can see the changes made. So pretty awesome feedback loop here. In my opinion, I think maybe one of the coolest new platform as a service offerings that exist because of how trivial it is to interact with it. And in addition, how much power you have in this thing, right? So again, I can just look at the logs. We see all the different stuff that it did. I can look at the application logs and see all the invocations here. I can look at it in CloudWatch. I can set up monitoring. Pretty cool service all in all. I can remotely call it. It's a nice nice capability that's built into this platform. So really the next step here, now that we got all this working, would be what we could do is check out the MLOps cookbook next, and that will be a good spot for us. So let's go to this repo, click clone, and then do this. So git clone, like that. There we go. MLOps cookbook. We go into this environment. We go Python MLOps cookbook. And then we can just say, again, we can say make install. And this should just go through, install all the software that we need. And then, in fact, I'll close all these windows so we can look at the right thing. So this MLOps cookbook repo, let's wait for this install to go. One of the cool things about this is that if I look at, for example, there's an app, and you can see Flask is kind of similar to FastAPI. It looks really, really similar here. And so we can actually just run something like this real quick locally here and just say, Python app.py. There we go. It's running in foreground mode. And if I just go to curl here, if I just say curl localhost, we can see that in fact it's running, right? That's just this route. And if I wanted to do a prediction, I wrote a little curl command here. We can even do that. We can just say predicts. So let's say, let's cd into, I think I nested it here. Yeah, so if I just go through here and I can just say predict, there we go. We got a prediction, and now we got a prediction service. So we're in great space here to now take everything we learned today and encapsulate it together to build this and put it into production. So as I talked earlier about this Python MLOps cookbook, which is from the Python MLOps book, it has a few components here that I think are really helpful in, if you're not familiar with machine learning or data science in particular, that will help you get up to speed quickly. And so if we click on this notebook to start with, this will be a good walkthrough. Notice how I used Open in Colab feature here. Let's go ahead and take a look at this. And in particular, what we do is I grab some data from this data source. I put a link to it, and I say import pandas as PD, and I really do a descriptive statistics dump here, or at least look at the first few rows of a data set. You can see this is a Major League Baseball data set, and it shows the team, it shows the player, it shows what position they're in, the height, the weight, and the age. And now I might want to look at the shape of the data, right? So, essentially, how many rows are there? There's 1,000 observations, 1,034 observations. There's 6 columns, right? Because there's the index column. So 1, 2, 3, 4, 5. So there's 6, including the index. So name, team, position, height, weight, age. And then if I want to drop any of the missing values, I can say, are there any null values? It looks like there are. So let's go ahead and drop it. And we found that there's one value, right? Because this is 1,034. If I do the shape again, we can see that whatever that one field that was empty, we just get rid of it. I also could clean up the column names. So this is probably pretty common when you're dealing with the data set, is go through here and clean up the column names and get that working. And then now let's do a little bit of descriptive statistics. Now also notice that, see how I use this scenario here, where I have ingestion, exploratory data analysis, modeling, and how clean it is for another person. They can go right into my project and start to see what I did and look through my thought process. So if we scroll through here, we can see describe, and this shows us height, weight, age. And here we do a group by operation, and we look at the median observation for that positional value. So for the pitchers, we can see that their median height is 73 inches and their median weight is 205. Look at the difference between, or I'm sorry, catcher, but look for a designated hitter. Their median weight is 225. And then if you look at the shortstop, that's the lightest. So there's a 50-pound difference, or 45-pound difference between a shortstop and a designated hitter. They're really beefy because their goal is to hit the ball as hard as they can. Where shortstop, their goal is to really be close to the ground and quick and light. And so there's some weight differences there. So if we look at this and I plot it, I can use Seaborn here and do an LM plot, and we can see the differences, right, between the weights. And you can see there's pretty significant differences here depending on what position you play. And there's, I think this is the shortstop and this is a designated hitter. Now, if I want to look at it by position, I can use the matplotlib and do a Seaborn facet plot, which I think this is a pretty cool plot. Especially if you have something where there's categorical variables like this. And so I can actually plot this out, and you can see that in this particular example, here's the catchers, here's the first baseman, second baseman, shortstop, third baseman, designated hitter. So you can see like these designated hitters are heavy, right? They're the bulkier players here, and then you look at the shortstop, which is right here. A very big difference in weight here, but we also can see by individual category, what the variance is. And now if I go into modeling, now we can get into, okay, what is training, right? That was a question someone asked, what is training? How does modeling work? So we're going to go through here and we're going to use these library tools. So from scikit-learn.model selection, import, train, test, split. We're also going to use a scaler. Most machine learning models require you to scale the data. So you're talking about the same dimensions. So for example, if you're talking about miles or feet, those are very big differences. Like if one column is miles, one column is feet. So you need to scale the data, so you're talking about relative comparisons. So if we go through here, we can select that, and then we can shape it, and then we can also turn this into a target, which is what we're trying to predict. And then we can also go to the feature, which is the value that we're using to train the model. So this is really what training is training something to predict a target by using these historical data. So here we have the X and we have the Y, right? Each of them are 1,033 observations, but only one feature. And then we go and we split the data and scale the data. So here we go. Here's the scaler. There we go. We fit it. We transform the data. Right, fit it, transform the data, right? And notice how that it now is actually a value between 0 to 1 because we're making everything relative. So we can compare apples to apples. And now you just take all these values and we split it up so that we save some of the data so we can actually validate our predictions not overfitting. And then we go through here and we fit the model. So this is the actual training code itself. This goes through and we say from scikit-learn, let's use regression. We'll use RIS regression here, and we just make an instance of it, and we say CLL, the model.fit. There we go. And then we look at the shape, and we look at the predictions, right? So we basically can take those predictions, and we can actually look at the unscaled predictions converted to a data frame and describe it, right? So we can see the differences, and we can actually scale we can actually do the inverse scale to view the predictions in a form where we can see, and then we can actually plot this out, right? And so we can see here's what the predicted height was, which is up here, and here's what the actual height was. So you can see it's doing a reasonable job, but in some cases it's over predicting, in other cases it's under predicting, right? Because but basically this is the predicted height, and this is the actual height. And then if we go to the accuracy, we can click on this, and it shows us the model score, right? So this shows us how much error our model actually has. So we would eventually, if we got more and more data and got more and more features and everything, we would be able to decrease the score, and that would be improving the accuracy. So that's really the gold standard for doing machine learning, is you want to keep training the model over and over again. In terms of the job lib, all this does is serialize out this model to disk. And in particular, we're actually dumping out this machine learning model so that we can then later deploy it into production. So there's lots of ways to handle the modeling. This is intentionally very simple because we're going to, from an educational perspective, use this. In a real world scenario, you most likely would use a framework like SageMaker or Azure ML Studio to version the model. Once we've got that, we can import it back in again. So I think this is a good idea when you're working with a model, is actually verify that you can load it back in from disk and there's not going to be a problem, and actually kind of test out how it would work. So here we go. We've reloaded that model in, and I can actually go through and get one observation and actually try to do a prediction. So I can scale the input, and then I can actually use NumPy here, and then go through and look at what the prediction value was. So unscaled prediction, transform prediction. So basically, what's nice about this is that I, again, can kind of go through here and step by step go through the things that I would do later when I deploy this model into production. So that's why I think that these notebooks are really invaluable as a companion to the machine learning prediction that I'm actually building for my MLOps pipeline. So we got all that working. Let's close this one actually. We got all that stuff working. And what we can do now is go back to our, let's go here. Let's go back to MLOps cookbook. And we can see that we now know how it works. We got everything working, but let's see if we can explore all these files. So let's start with the command line tool here. If I go to this, you saw that I was running this prediction here, which is kind of neat. But what if I also want to use a command line tool? If we go to this aspect of what we're building, notice that I have the click framework, which is a command line tool framework, and I use click.option, and I have the weight, right? So this is -- weight, and it accepts that as a parameter, and I can actually create a prompt for it, and then I even can have a help menu that shows me exactly what I'm building. And then to build a machine learning prediction, this is probably the simplest possible way to do it without building anything, is to build out a command line tool like this that you're able to actually push that into a function. And in this case, this is a predict function. And so where is that predict function? Look, I created a library called MLlib. And then inside of that library, we can actually take a look at how that works. So let's go look at this. So a lot of that boilerplate code that I was playing around with earlier in the notebook, now it pays dividends because I can just take those pieces and build out a machine learning library that I can use for many different tools. So here's an example. I say import NumPy as PD. Import NumPy as NP, import pandas as PD. From scikit-learn import. From scikit-learn import ridge regression, import joblib. From scikit-learn.preprocessing import standard scalar, import joblib, etc. I import all those inside of here, and then I have a piece of code that can grab that from disk, right? So that's that serialized model. I have another function here that just grabs the CSV file that has the raw data. And notice right here that I build a function that can retrain the model, and I can actually overwrite that model. Now, there's a bunch of different ways we could do this. We could also create new files or however we want to do this. But notice what I do is that I do all the scaling, transform everything, and then I can just tell it, for example, this is one way to retrain it would be to pull up the training size, but you could also pull hyperparameters, or you could pick whatever it is you want to do to actually get this thing to retrain. And then what's neat about this is I can actually build a web app, or I can build a command line tool that can actually use this retraining. So just again, it depends on how I want to retrain the model. Do I want to retrain it by picking different test sizes, or do I want to pick different hyperparameters, or what are the things that I care about when I'm doing a retraining? This is just, again, more of an educational example where I just fit a different test size in here, and then I return back the results of the model and write a new model out. I also have a piece of code or a function that formats the input. So this makes it able to be used as a feature. I have a function for scaling the input. I have a function for scaling the target. I also have a helper function that allows me to build out the ability to convert inches into height and basically feet in inches. So I'm able to do a human conversion, and I also can make a human readable payload. So later, like for example, this prediction right here, where it says prediction, human height, readable, 6'2", etc. All that is something that's done via this human readable payload. So you can see there's a little bit of code. I mean, not a ton, but there's a little bit of like helper code here that if you put it into a library, it really pays dividends to use it over and over again, so that you can actually build many kinds of tools. And then finally, I could build a predict function, and that predict function really just does a machine learning prediction, and you can see it returns back a payload. And that's really our library. Now notice if I go back to this command line tool, look, I just say predict, right? So it's able to use all of that really cool stuff that we built earlier by just one line of code and import. And that's why if I want to use this tool, and here we go, CLI, let's go ahead and try this out. If I say CLI and I just do help, well, first of all, I need to source the Python virtual environment. So what we can do is we can just say source ~venv bin activate. And once I do that, I can actually run this help command. And this help command will show me that this is a command line tool that predicts the height of a Major League Baseball player based on the weight. If we pass in -- weight, that'll give us the weight of a player that will predict the height. So, okay, let's go ahead and do this. We'll put in the weight and we'll say 200. And here we go. We predict that this person that's 200 pounds should be, 6'2". And if we put in 220, we predict they would be 6'3", right? So we're able to take all those values and build a command line tool. And notice that I'm even able to do this cool, colored output as well. And that's something that's available via this click echo command here, where I'm able to add like a green background and a white lettering, right? So there's some pretty cool little tricks you can do by building command line tools. So I like to do this in a project. Again, is have not only the DevOps stuff like the make file, the requirements file, but build a library for machine learning that can do a lot of the heavy lifting for me. So later I can build multiple utilities, including the microservice, which is the app, and the command line tool, which we're doing for prediction. Now notice there's also this, which is a second tool called a utilities CLI. And let's go ahead and take a look at how that works. If I go back to the code here and I look at this utils function, what this does, again, it uses the click library. It again imports that central library, is that it allows us to do a retrain. So remember I had that retrain function. So now I can just pass in a training size. And then if I run retrain, it'll actually go through and retrain the model. So let's go ahead and try that out. So if I go through here and I say utils CLI and I do -- help, it will show us that we can do send a prediction, or we can do a retrain. Let's go ahead and do a retrain. So let's go do that. And we can even ask for help for that as well. So we can do --help. And it says you may want to extend this with more options, such as setting a model name. Okay, and retraining here, let's go ahead and do this. We'll go ahead and say -- t size, so training size, and let's do 0.2. So we'll go ahead and retrain the model. There we go. It retrained the model, and look, it's actually got a little bit better accuracy. So we're able to kind of maybe experiment. We could even write another script that sits on top of this, and it could train a whole bunch of different kinds of models, training size, or if we let this function accept hyperparameters, we could try a bunch of different hyperparameters. But in general, this is the spirit of retraining, is if you can hook things into an automation system, like maybe a build process or a training process, you could try a bunch of different iterations, or even if you use a framework that does this, it could do a lot of the retraining for you. The other thing that I added in this particular function that you saw here is that, look, I even wrote a little wrapper that will allow us to call an existing web service and invoke it without having to do a curl command, which is kind of a nice thing to be able to do. Notice that I used the Python request library to make a post request, and I actually passed in a JSON payload. So I think this is also potentially something really useful. Now notice that by default, right, this is already running on a port, localhost 8080, or actually it's running on the actual IP address of the server, but it should also be available on localhost. So what I can do is I can say util CLI, and we can say, again, what is the name of our, I think it's called predict. Okay, let's go ahead and do predict, and let's do -- help. And you can see here that basically it's asking for weight and host. I think by default, we don't have to do anything. Let's go ahead and try. There we go. So by default, it was able to make a request to this particular payload, and there we go. Now, if I did then eventually deploy this using the AWS app runner, then I also could invoke it there. So let's go ahead and do that next here. Let's actually, now that we've got this whole thing end-to-end working, let's now take this application and use our fancy microservice framework here, our hosting service, to actually fully deploy this. So how do we do this? We say create service. We can either pick a container registry or a source code registry. Let's go ahead and pick a source code registry here, and we'll go ahead and say Python MLOps, cookbook, there we go, Python MLOps cookbook. And we'll say, in this case, we could choose either manual or automatic. We can get a little brave here and pick automatic and see what happens. And then it says configure all the settings. We'll say Python 3. So we'll do pip install -r requirements.txt, and let's just look here real quick, because I think I showed a picture of this at some point. I think I had a picture of it working with App Runner. I don't remember what I put for the settings though for App Runner. I believe though we can just say Python main though. So I think we can just run the same thing we were running here. So if I just say history, we should be able to just say Python app. So let's go ahead and do that, and let's try that, Python app, and we'll call this MLOps cookbook. There we go. Leave everything default, and we'll just give this thing a second. Oh, whoops! And it's got to do a. Let's see here. Let's try that. Okay, so we'll create and deploy. So it's gonna attempt to create this MLOps cookbook, and then we can see basically what happens with that. The other thing that we can also basically experiment with is if we're able to go through here and make changes to the model. Once this thing is actually deployed into production, it will actually redeploy that application automatically. And so that's one of the big changes that we made. So actually, let's just pause, because this will take about 5 minutes to deploy. What I'm going to do is I'm going to go back a little bit to our other project, the FastAPI project, and notice that the FastAPI project, remember, was right here. I'm going to close all these other ones. That do you remember it had this Docker file right here? So remember this Docker file, and in particular, I think I'm going to need to move this MLOps cookbook. So let's go ahead and mv Python MLOps cookbook up one. There we go. So we kind of moved it out of here. But notice that this thing is allowing us to use Python from the Amazon Container Registry, and it copies the app. If you remember, this is the original app, really simple Flask API thing. I also wanted to show how we could containerize a model while that other one's deploying. And so again, this is a Docker file. So all we need to do, if we go to the README file, is you could just do this. You could say Docker build. Let's go ahead and run that. This will run this locally. And then once this thing is running locally, this will take a second. We should be able to run the image and kind of test this thing out. Okay, so we got this thing working in the container. Okay, this thing looks like it's working here. And there we go. Okay, so now if I say Docker image ls, we could see that this image was built right here. So now I can just run this. I can just take this, paste it in, and then take this image ID like that, 8080, and just run it. And does it work? Now it's running in foreground mode. Great. If I then curl this, if I just say curl localhost, or I think it would be 127.0.0.1 and 8080. There we go. So this actually works. So this is a containerized version of actually that FastAPI microservice. And so the reason I'm showing you all this is that what we can do, as well as this thing's still cooking here, is we can go to the Amazon Container Registry service. So it's called Elastic Container Registry. We can register a new container. Let's go ahead and do that. Let's just say create repo, and we'll just say like more FastAPI like this. And then we can actually go ahead and create a repository. And inside of this repository, we see this more FastAPI, right? This, that notice that we can say view push commands. Now all we need to do is copy this, go back to our AWS Cloud 9 environment and log in. There we go. And then we just also go and we build a new container. So let's go ahead and do that. Let's build a new container, and we're going to call it a certain name. Great, that worked. That's what that label did, right? So we're basically labeling the container called more FastAPI. And then the next thing that's going to ask us to do is to tag it. So we'll go ahead and tag it. And we'll do this. There we go. And then the final thing would be to push it. So we're just going to do this. We're going to say Docker push like that. So we're going to copy this, and then we're going to push it. So once we push this container, what's really cool about this is that we can also tell AWS App Runner to deploy a container, right? So this App Runner thing is a little bit like one of those blenders that shows up in late night TV. It does a lot of stuff, right? It grinds everything and creates a cool smoothie, right? A MLOps smoothie from AWS App Runner. So let's let this thing push real quick. And once it's finally pushed, then this container registry allows us to utilize things inside of there, which again is pretty cool concept. So let's go ahead and let this thing keep going here. There we go. 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 It's going. And almost finished. Okay, so this thing's pushed now. Now if I close this and I refresh it, it should show up. There we go. So now we got an image now that we can use for App Runner. So I'm going to go back to App Runner, and we'll actually go back to this cookbook in a second. But let's make a new one and create a service. This time we're going to select Container Registry, and I'm going to use Amazon Container Registry, and we can actually enter a URI to an image that you can access. So we want to go to this, which is copy this URI, and we want to go here, and we just want to paste this in. There we go. So that's the image URI. And now we can say, let's just do manual to keep it simple, and we'll use an existing role, and we'll go to next here, and we'll call this FastAPI container, like this. Port will be 8080. We'll leave all that going here. We'll say next, and there we go. We can say create and deploy. So this one is even simpler because remember that the container itself is invoking the Python app or Python main. So really we just need to specify the external port that we want to expose. So this again will take a few minutes. So again, we'll come back. We're kind of letting this thing cook. Let's go back to our MLOps cookbook for a second, which is right here. And so what we can do is if we click it, we can see, there we go. We got this machine learning application and it's working. And in fact, we can also, if we go, let me just CD into the directory that has our MLOps cookbook code. We can actually use that utility that I wrote here, and I can just say help. And remember how it had a prediction function, right? So I can actually say predict, predict. And remember how it said I can change the URLs, the host URL. So basically I can just do this. I can say host, and we can just take the name of this URL, which is right here, just copy it. And I can throw that in here. And then I can also just do the weight, dash weight, and we can just say 200. And for some, oh, I need to put predict on here, like this. There we go. There we go. So now I've got a working production deployed service that does MLOps. And even better is it's all set up for doing continuous delivery because of the fact that I put that option on the the way I set it up. So in fact, if I go back to my MLOps cookbook here and I just like change something, so if I go to this repo and just put like a dot so it triggers the build, we can just go like this, dot. Or let's even be clear, we'll just say push build or push deploy like this. This will push the deploy, go through and make a change. There we go. And now if I go back to my app runner, check that out. It already started a deployment process. So we've got full continuous delivery of an actual MLOps project. And so again, in my opinion, this is a pretty slick service because of how awesome it is that it makes the process of continuous delivery, and it encapsulates, if we go back to this document, this entire thing is completely encapsulated basically in this one service. So it's kind of like a magic service because it just shrinks the complexity of what it is that you're building so that you can build a command line tool. So really, really cool service in my opinion. So now that we've got everything working, the final thing to do is if I go back to App Runner, let's double check the container. Remember this one? And this is the other thing that I'll mention. This will take just a second, is that what's kind of cool about the container approach is that it's a little bit simpler to get the continuous delivery, continuous deployment set up because it's already doing part of the task. Additionally, what's kind of cool about it is already packaging the runtime. So essentially someone or another process, even like the AWS build system, could actually build these containers automatically. So even another team could be building like tons and tons of microservices. And then I might be more the operations side of things. I could pull those images down and just link them into a process like this. So once this is complete, we should be able to invoke this thing. And again, its original source was actually this container, right? And not only that, can the app runner run this container, by the way, but anything in AWS can run it. So I could even do a Docker pull from another Cloud9 environment and actually invoke this thing as well. And so maybe I'll even since the container's finished, we can play with this. So let's go ahead and see if it works. There we go. So now we know even a containerized version works. So it's probably worth just saying everything we did and documenting a couple of these workflows, because there's a lot of cool stuff that we accomplished. So eventually, let's get this cooking here. So what did we actually do? So we had the GitHub project here, right? And we set up continuous integration, right, with the GitHub Actions, right? So this was the build server, right? And so this is basically improving the quality of our code. So we'll say improves code quality. And then we'll call this, DevOps and MLOps plus MLOps. The other thing that we did was we used a cloud-based environment. So we used AWS Cloud9 here. And what was great about the Cloud9 is it has all this deep integration with AWS, and we deployed several things. So we basically use this as a development environment. So you could think of this, we'll call this dev environment. We essentially were able to build out microservices and all kinds of stuff inside of here. So we can say microservice. And then finally, what we were able to do was use AWS App Runner. And with AWS App Runner, we had several different kinds of projects that we deployed. But one of the projects used, and we'll put it up here, ECR, which is a container registry. And so what was cool about that is you can basically just take containers that some other service builds and deploy them. We also told App Runner to listen to GitHub, right? And that's another one that it did. And then we even had a couple flavors of how we did App Runner. One was we did manual deploy, and then another one we did was we did auto deploy, right? Which would be continuous delivery. So we did a lot of stuff inside of here, lots of different environments. The other thing as well that we did that was kind of nifty was we have a command line interface, CLI, that also allowed us to invoke the library. So really this is essentially like a fairly exhaustive collection of how to do continuous integration, how to use a cloud-based development environment, how to set up things with this pass, and then also how to do deployment of APIs using FastAPI. So we can even say as well here that we use both FastAPI and we also use Flask. We use two flavors, and we're able to use both containers. We're both able to use GitHub. We also do manual, also do continuous delivery. So between all of these different kinds of things, I think this is a good, I would say, foundation for doing MLOps. It isn't covering exhaustively more advanced things like continuous training or using platform tools. But I think this is a very good foundation to be aware of what are the key components of MLOps, right? DevOps, cloud-based development environment, and then also these microservice frameworks. So I think this is a good place to maybe stop for a second and collect our thoughts. I'm going to go ahead and just clean everything up here just so that I don't have too many things running. So I'm gonna close this shell, and I would always recommend to kind of clean things up when you're done. So let's click this, we'll close it out. Also, another thing to be aware of is that you do get charged by all these, and so it's probably a good idea to also clean them all up so you don't get charged. So I'm gonna go through here, I'm gonna say delete, and then each one of them will have to go through here and delete. And I think this is something that maybe people don't always show is that you do want to clean up your demo resources or student projects or whatever you're prototyping, or else you're going to get yourself into a little bit of trouble because you're going to get a big bill from what it is you're doing. So we'll go ahead and delete this thing, go ahead and go to this one, we'll go through and we'll delete it. There we go. Here we go, delete. Now, fortunately, Cloud 9, which we cleaned up, is pretty easy to, it'll just, when you shut it off, it'll automatically time out. So you don't need to necessarily delete that unless you've stored a lot of things on it and then you would get charged by the storage. But there we go. So we've got everything deleted, cleaned up, got everything ready to go. So let's go ahead and potentially move over to answering some questions here and wrapping things up for the day. So I see there's a question that says, let's go here and say push the slide area. So can we use Apache Airflow or some other ML pipeline tools on Cloud Platform? Sure. Yeah, you can use, some of them have these built into it. I believe that these tools, the open source stuff, eventually they all come into the cloud platforms where they become part of a managed service. Or the all other thing is you can always run any open source tool. So yeah, I think using Apache-based tools typically, eventually either become a managed service by AWS or Azure, etc., or you can always just deploy them yourself. And next question here is, so what if a team member is using Conda? I guess the power of this won't matter. They'll be developing the cloud, not their laptop. Yeah, I think that's a great question. Conda does come up a lot. And, for some reason in Python, there is this thing where people really want to create packaging tools in Python. Like there was easy install, there's pip, there's Conda, there's like PyEnv, there's all these different tools. Conda, I think, works pretty well for if you're using your desktop and you're doing biology and like data science on your desktop and you're not as concerned about deployment. That seems to be really the sweet spot for something like Conda. I think that it doesn't hurt to use Conda. It seems like a pretty good tool, but I think for the cloud, I think the virtual environment right now is kind of the way to go. And it doesn't preclude someone doing things with Conda, right? It's just a separate process to use the Python virtual environment approach. And okay, so those are basically the questions that I had. And so, maybe I can kind of wrap things up here and just talk about in terms of, next steps and things like that. So I do think that in terms of, if you want to keep going deep on here, we only covered a couple chapters. We covered Introduction to MLOps, and then I also covered the MLOps Foundations, and then I also got a little bit into this chapter here, which is MLOps for AWS, and that's where I got into the cookbook. But basically, we only were able, from a time perspective, able to really cover a little bit of stuff. But I would, if you have some time, go into the O'Reilly platform, read a little bit more through some of the chapters. And in particular, there's a lot more stuff on AWS if you're interested in AWS. The other one that I think is a good chapter to play around with that I'll just maybe talk about for a second is this AutoML and KaizenML chapter. And in particular, with AutoML, I think one thing to think about is that we didn't really get into it that much, but you don't need to build it to use it, right? Like, if you go to Costco, you can grab a pizza that was already made for you, or you can grab one that's frozen, or you can grab, maybe like one that's like the raw ingredients. They're all different levels of abstraction. Same with machine learning. You can do machine learning from scratch. You can train a model, yourself, or you can use AutoML, or you can even use an API. And so that's, I think, an important distinction to be aware of that isn't really covered that much, is that you don't necessarily need to build it to use it. A couple other things I'll mention as well, if I kind of scroll down here a little bit, is that I think this is something that I've seen a lot, is that everyone seems very fascinated with this behavior, of data science. Like, hey, data science is wonderful, which it is, critical thinking around data. But think about this from a systems methodology, that really data science and even doing things like AutoML, this is a very, very tiny part of the whole systems methodology. You have to do automated feature engineering, automated testing, automated deployment, cloud elasticity, auto scaling, drift detection, auto data engineering. So there's a lot of stuff involved other than just the data science here. And I think this is really what MLOps says, is that you need to constantly be, automating things and improving things. And that's really the essence of Kaizen, which, Kaizen ML, or constantly improving. I'm going to show you one other thing as well, which is that the feature store here, I think, is another interesting thing to think about, is that, and I know this was asked by someone, was, let's go to this and open this up, and open a new tab. Here we go. Yeah, so basically, think about a feature store here, that you have 1.0 data science, everything's right here. You have low quality data over here. You have manual processes. But then if we get into data operations, you're starting to automate this whole process of cleaning the data, validating the data. And that's really where the feature store comes in, right? Is that inside of a feature store, you're able to actually have this high quality set of features that you can use for doing what we just covered today, continuous delivery. You could also use it for AutoML. You could also use it for elastic inference and elastic training. So that, again, this is my opinion for this concept of Kaizen ML, or constantly improving, is that you must go from just the data is just thrown inside of some location somewhere into automating things into a feature store. Now let's talk for a second as well a little bit more about the feature store. If we scroll down here, there's a good example of the difference between a let's scroll down here. Here's a difference between a feature store and a data store. Is it this one? Yeah, let's scroll here. So what is the difference between a data warehouse and a feature store? So in a data lake, which is again like something like Amazon S3, you could have the streaming data, you could have the batch data, and inside of here, you move this ETL pipeline, and you have stuff inside of a data warehouse. So again, this is like a high level, business intelligence type tool. And what are the outputs of that? Well, the outputs could be reporting, the outputs could be dashboards, the outputs could be business intelligence. And so it's very different in that you're building something so you can do reporting. But for a feature store, really the human is the one that's actually the customer. But in terms of the data lake here for feature, you're building something where the customers are machine learning systems. And so you're trying to do prediction, training, you have clients that consume this data. And so I think that's the best way to really reason about the differences between a data warehouse and a feature store. And what is a feature store is this is for humans and this is for machines. And that's why you're building a feature store. As a data warehouse is really designed for reporting things. A feature store is designed for training machine learning models, and you still need some of the same processes for both. Okay, so that's probably a good spot here to kind of wrap things up then. And we have a little comment that someone has here, which is that, let's push this to the slide area. So thanks, I'd like to see examples of complex enterprise products and what MLOps best practices applied in a nutshell. Yeah, so then I think that the next steps would be things like, this is the foundation, but, what about how would like a Tesla work, for example, or something like that. And I think with those kind of scenarios, it's really going to be a case-by-case basis. But I was able to actually go to, and maybe I'll just briefly talk about this. I was able to go and hear about how their system works. It's similar, the similar concepts, except for things are more complex, and that instead of deploying something to an endpoint, you're deploying it to a vehicle, and there's a piece of hardware. And so the difference would be that you would have to take that hardware and actually have it in a lab somewhere, and your build systems would go and push that code to a piece of hardware, like the full self-driving board. And so it is very similar in conceptually, except for you're using bigger tools and different endpoints.